Hi everybody. On this video, we're going to be going over everything that you'll need to know for homework 13 and 14 notes. Now you'll have two homework assignments on My Open Math, one for homework 13 and one for homework 14. But a lot of the topics are kind of intertwined together, so it's just easier to teach all of this as one, and then you'll have your two assignments. Okay, so we're talking about statistics. It's collecting, organizing, summarizing, and analyzing information so that intelligent conclusions are made. So it's taking a bunch of data or maybe a bunch of numbers or other things and kind of arranging it to where you can analyze it and use it for something. Now, a statistic can be just one value. So statistics can be talking about a whole field of, a way of analyzing information and summarizing all that. And statistic can also be just one calculated value. Okay, so we're going to go over some of these buzzwords that you're going to need to know. So a population of a study is the group that the collected data is intended to describe. So it could be like maybe all Americans. Maybe they're wanting to describe Americans have a tendency, blah, 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 or something. So, or the population could be college students between the age of 18 and 22, or between that are maybe students that are 18 to 40 or something like that. I don't know, but it's that's the population, like everybody that's in that population. Okay, a parameter is a calculated value, average, percentage, etc., any of those things, using data obtained from the population. So parameter goes with population. So a survey of an entire population is called a census. And we're actually having a census in 2020. Every 10 years, they try to interview or get information from every family in the U.S., really just to get a count of how many are in each household, and they use it in order to get additional funding for roads and that kind of thing. And also like how many electoral college votes that a certain state has, or it's kind of a lot of different things. But the main thing might be to get federal funding for certain things. They want to be sure and count everybody. So it's really just a survey. But a lot of people are like, oh, I don't want to give any information to the census. Well, they're going to use that as a collective thing. They're going to put all the information together. And it's kind of like just doing a survey, but it's for everybody. So a lot of times if you don't turn in your census information, they'll eventually come knock on your door. I've had a friend that had that as a job. She would go find people that hadn't answered and to just try to get them to answer a few questions so that they get the information that way. Okay, a sample is a smaller subset of the entire population. So it's just a subset of it. And a statistic is a calculated value obtained from the sample. So a parameter is an average or percentage or something, is data obtained from the population, where statistic is obtained from the sample. So those both start with a P, these both start with an S, so maybe that'll help you remember which one goes with what. Describe the population sample of the following. You conduct a poll in which you randomly select 1,000 registered voters from Texas and ask if they approve of their job, the job that their governor is doing. So let's talk about what the population is and what the sample is. So population. Population, remember, is the whole big group you're referring to. So you conduct a poll in which you randomly select 1,000 registered voters from Texas and ask if they approve of the job their governor is doing. So you randomly select 1,000 registered voters from Texas. That's the population, is all of them. All registered voters. Oops, in Texas. Where the sample is, I shouldn't have underlined all that. But this 1,000 registered voters from Texas tells us really both. So the registered voters from Texas is really all of them. Oops. And that's what is over here, all registered voters in Texas. I didn't mean to cross through that. And the sample is 1,000 of them. So remember the sample we take from the population, kind of a subset of it. So this is the 1,000 registered voters in Texas. So it looks very much the same. It's not letting me write. Okay, so the population again is all of the registered voters, where the sample is only 1,000 of them. Okay, the next one, to determine the average length of trout in a lake, researchers catch 20 fish and measure them. So what would the population be? It's actually going to be all the fish in the lake, in this one lake. Now, are they going to take all the fish out? And they could take all of them out, and they would know the exact, whatever's going on with them, they could measure them or whatever. But that's they don't want to do that. So they just want to take a sample. So they're going to take a sample of them out. The sample is the 20 fish that were caught. So they're going to measure those. Okay, a high school student newspaper plans to survey local business about the importance of students as customers. From an alphabetical list of all local businesses, the newspaper staff chooses 150 businesses at random. Of these, 73 return the questionnaire mailed by the staff. So, the population it's not going to be, you wouldn't say all the local businesses, because really they choose 150 businesses first. And then of those, that's really going to be your, let me see something. Oh, I'm saying it wrong. So, okay, this is where we got to look at this. Let me read it again. A high school student newspaper plans to survey local businesses about the importance of students as customers. From an alphabetical list, they choose 150 businesses at random, and of these, 73 return the questionnaire. So the 150 that they choose would be their sample if they all sent them back in. So the population is really all the local businesses. Okay, so I was thinking about it wrong at first, but it would be all local businesses. Okay, so remember the population is kind of like the group that you're talking about at this point. Just like the last example, we're talking about all the fish in a lake. The one before that, they're talking about all the registered voters in Texas. Now they're talking about all the local businesses. That's the population. And the sample, we can't say this is 150. If they would all turn them back in, that would be their sample. But they can only use the ones that are returned as part of the sample. So the sample is really the 73. 73 of them. So let's say there was 1,000 local businesses. I don't know how many there were. Out of those, they choose 150 at random to send stuff to. out of the 150, only 73 got back with them, but that's what they'll use as their sample. They're going to use that information. They didn't get information from the rest of the 150, so they're not part of the sample, just the 73. A college reports that the average age of its students is 28 years old. Is this a statistic or a parameter? Now remember, a statistic goes with a sample. Remember that? And a parameter goes with a population. So we have to think about this. A college reports that the average age of its students is 28 years old. Is that a statistic or a parameter? Okay, so this is really going to be a parameter because it's dealing with, they can get in the information from all the students at a college. They'll know how old their students are. They can run a report that says what are the ages of all their students. So they have access to that. They can get info on age of students. Now, of course, I wouldn't have access to that, but they can. There's only certain people at the college that could run a report on the ages, and normally what they do is they don't have names or G numbers or anything on there. They just run a report like, okay, here's the ages. So okay, so the parameter goes with the population, and since they can get the information on the age of all the students, then that's why we're doing parameter. So if they're asking you why, you could say, and usually we do, like on a test, we may say, well, why? And in this case, because the college would have access to data on all students. Which is the population. So it's population because they'd have access to all of the students there at the college, and that's population. So it's going to be parameter because it deals with population. Okay, qualitative data and quantitative data. Qualitative data deals with various categories. And a lot of times it's stuff that's written in words, but not always. So categories is important. And then quantitative deals with calculations, and sometimes it's something you can maybe take an average of or something. It has arithmetic in it, arithmetic calculations, but maybe even something you can take an average of. So let's look at these. Gender. Gender's male, female. Can you take an average of that? Is that like a number? No, but it's a category. That's qualitative. Oops. Because we're talking about categories of gender. Oops. Gender. Temperature. Okay, temperature can be something like 72 degrees, 36 degrees. We could do something with that. We could maybe do some sort of calculations with that. Or maybe take an average of, this week it was been 72 degrees, and then it was 46, and then it really warmed up to 80, and then it dropped back down to 50. We can kind of come up with an average. Well, the average temperature this week was blah, blah, blah. So that is quantitative. Just like quantity is how many you have of something, quant is dealing with how many you have of something. And you can take an average of it somehow. So this is quantitative, or quantitative. Quantitative. Seems like I've said it wrong before, so I want to make sure. Because calculations can be found, or we can use calculations on that. How much hotter was it this day than that day? Can we find the average? We can find the average temp, and that's a huge thing. Average temp. Hair color. Well, there's some people have red hair, some people have blue hair now. They've dyed it. Or dark hair, black, brown, yellowish, blondish, light brown. My sister always claimed she was dishwater blonde. It's like, oh, because she was real dark blonde, and she'd say, it looks like after you wash the dishes and the color in the sink. I'm like, that's just, you got to come up with a different name than that, maybe tawny or something. I don't know. Anyway, I've always had brown hair, but okay, but you can't take an average of that, can you? Like, you can't say, okay, you've got dark hair, you've got light hair, the average would be like reddish, brownish. I don't know. You can't really do that. So that is qualitative. And a lot of times it's kind of, anytime it's in words, that you're dealing in words like that, is qualitative. Another way to think of it is you're talking about categories of hair color. Zip code. Now, this is interesting. (90210). No, that's in California. I'm just making up 2 zip codes. Now, those are numbers. So you think at first glance, oh, that's got to be quantitative. Because dealing with a quantity. It's got numbers in it. But can you take the average, or do we need calculations with that at all? No. So that means it's qualitative. So that's one of those that's a little bit tricky. Because you're thinking, oh, numbers is one, words is the other, but not necessarily. Sometimes we have numbers that we're not going to average, or we're not going to use to calculate. You wouldn't say, want to compare those. Like this zip code, where is it in relation to that one? Well, you wouldn't take the difference between them and subtract it. That just doesn't make sense. So let's go on. Height in inches. Now, height can be like 62 inches, 47 inches, and things like that. So you can do some calculations with that. You can say, oh, this one over here is, 18 inches taller than that. You can kind of you can compare, and we can even take an average height of college men that are from age 18 to 30 or something. But you can take their heights, and you can take an average of that. So it's quantitative. I apologize, I don't write very good with this. Since it's a calculation of height, and being able to do an average of it is a real big clue. Okay, last one. Number of times a college student works out. So maybe they took a survey and a bunch of kids filled out the survey. This kid over here works out 5 times a week. This kid 1 time a week. This kid, doesn't. Or, and then you can take all that, kind of come up with the average college student spends about 1.2 hours of working out, or maybe you come up with something for the week. Average is about 2 to 3 hours of exercise per week or something like that. So that's quantitative. Calculations can happen. We can come up with the average time a college student would work out. Okay, let's move on to sampling bias. Bias means it means you're kind of like maybe somebody giving a sample or doing something that kind of leans a certain way, and they kind of inadvertently they don't try to, but they may even not be meaning to influence something. Or, well, let's just look at this example. Oh, wait, sampling bias occurs if every member of the population does not have an equal likelihood of being in the sample. So maybe you go take a sample from a school, that goes through the 12th grade or something, and you're really trying to get all students that include college students. Well, it's a sampling bias, because if everybody that you're sampling or asking questions from is high school, then you're not getting a true picture of it, because you're not getting any college kids in there. So we need to have every member. Okay, sampling bias occurs if every member of the population does not have an equal likelihood of being in the sample. So let's look at this. In November 1998, former professional wrestler Jesse the Body Ventura was elected governor of Minnesota. Up until the election, most polls showed he had no chance of winning. Okay, and that happens a lot. That actually happened in the last presidential election. All the polls showed one person was going to win and the other person won. How does that happen? Well, now this is also talking about a governor, and most polls showed he had little chance of winning, but he won. He was elected governor and he won, but all the polls said he had little chance of winning. It says many respondents to polls may have been embarrassed to tell pollsters they were planning to vote for a professional wrestler. Okay, maybe they just asked them, hey, who are you going to vote for? And they just said, I don't know. Or maybe they said the other person, because they just didn't want to say they were going to vote for the wrestler. Maybe they were made fun of for that or something. I don't know. Okay, so Ventura is the wrestler, recruited a substantial amount of support from young people who had never voted before. The polls did not deem these young people as likely voters. So the polls, meaning maybe they were calling people. Maybe they didn't call and ask for the 18 to 20-year-olds. Maybe they were asking the parents or something. Now, it could be that they were set up at a mall or something, and as people walk by, they're like, hey, can you come answer this? And maybe they were targeting older people. They're saying, oh, that person looks like they're in their 20s or 30s, or they've been, I'll ask them. And they don't even realize they're not even trying to find the 18-year-olds, the 20-year-olds. So that's what can happen with sampling bias. So it could, another example would be, sometimes the people that answer polls, maybe if they're calling on the phone, most people are too busy for that. I'm going to school, I've got a job, I've got kids, and I've got somebody calling me. I don't have time to answer the questions. Well, who's going to have time to answer the questions? Sometimes it's maybe it's if you call at a certain time of the day and you only call at that certain time of the day, you're going to get people, a different type of person. If you call, that maybe isn't as busy, maybe they're not working. But if you call in the like 8 o'clock at night or something, you might get more of the ones that are working a full-time job during the day. And also, a lot of times people that answer these polls are the ones that feel strongly one certain way or another. Some that are undecided, or they're kind of leaning one way. They may not take the chance to the time to do this. But if somebody feels very strongly, they're going to answer the poll. So that could be, either way, no matter which way they were going to go with their vote, it could not give good information. Okay, so simple random sampling. So these are going to be talking about types of samples. So let me write that in. Types of samples, or sampling, like the process of getting a sample. We've got simple random sampling, and it's just kind of what it sounds like. Simple means it's not very complex. It may be just, you've got names put in a hat, and you're just sticking your hand in there and pulling out, a name, and that's it. And random means that there's no system to it. You're kind of like you're just putting all the names in a hat, and you just pull one out. So we choose a sample of items in such a way that every sample of the same size has an equal chance of being selected. So that's important. Every sample of the same size has an equal chance of being selected. Example: identify all likely voters in the state, put each of their names on a piece of paper, and place into a hat. Draw 1,000 slips out of the hat. That's simple random sampling. Now, we have computers that do that now. If they were going to, wanted to ask certain people in the state that, of all the likely voters, of course they're not going to go put their names on something, each little piece of paper, and fold it and put it up in this hat and then draw one out. But you can. This is what I've seen people do at either carnivals or even at church sometimes, like on Mother's Day or Father's Day. Sometimes you get a little ticket and you can put your name on it and you put it in the kind of the hat, and they end up later in the service they'll draw one out and somebody wins something. But are you going to be able to identify all the likely voters in the state and put their name on a piece of paper and place it in the hat? If you could do that and then draw out 1,000 slips out of the hat, that is simple random sampling. So a lot of that's done on the computers now. Systematic sampling is just like it sounds. There's a system to it. We use a simple system to choose the sample, such as selecting every 10th or every 50th member of the population. So it says a pollster calls every 100th name in a phone book. So they have names listed. So they go through every 100th one. They'll circle, oh, that's 100. Now start over. 1, 2, 3, 4, 5, 6, 7, 8, all the way up to 100. Okay. So that may be a good way to do this, because at least you don't have as much of a chance of having everybody maybe with a similar last name or something like that. It's going to be everybody. It's going to be 100th name out of the whole phone book. So it's a little more diverse maybe. Now because with random, you could end up picking, 30 out of 50 of them, maybe in a certain age group, for instance. And maybe what they could do is systematic is you put them in order of ages from least to greatest, or the oldest, and then they do every 100th one, or every 10th one. So at least it's kind of spread out over everybody. Convenience or opportunity sampling. We choose a sample that is convenient to select, such as people who happen to be in the same classroom. Now, a lot of times professors will do that if they're wanting to run some kind of, I shy away from experiment, but maybe they want to know, for instance, if we do a flipped classroom in this room, I wonder how it would compare to another. This is getting a little bit too much into it, but they may want to try something like, maybe a professor has 2 different classes, and they're both students doing things kind of like y'all are doing at home. So a flipped classroom would be you guys all watch the video at home, and there would be no instruction in class. You go to class, and you just work on homework and have your questions answered. And it sounds like that'd be kind of cool to do, but it doesn't work unless all the students will watch the videos and the lectures. And we've had trouble with that because there's always going to be students that don't want to do the homework. So if they're not going to do the homework, they're less likely to watch the videos. And so they're asking too many questions and getting you to lecture in class as well. So it doesn't really work. But that's kind of what this is talking about. Let's sample. Let's take a sample. I'm just going to use this class over here and compare it to this class. In one class, I may do the flipped classroom thing, and the other one I'm not. But that's convenience. It's whatever the opportunity is there. And then this will be another example. A pollster stands in the street corner and interviews the first 100 people who agree to speak to him. So that's kind of convenient. He's standing in one spot, and just whoever comes up to him, I'm just going to ask them, and that's all I'm going to do. I'm not going to try to he's not going to try to stand there maybe at different times during the day and try to get different, maybe people that work early in the morning, people that are coming off from working all night long or something like that, the ones that are taking a lunch break, and then also maybe at the end of the day. Like, they're not trying to do that. They're just going to get the first 100 people that come up to them, and that's what they're going to do. Convenient sampling. Now, stratified is interesting. We use this method when we're concerned about the differences among subgroups or strata within a population. We identify the subgroups and then draw a simple random sample within each group. The total sample consists of all the samples from the individual subgroups. So let's say you were doing a sample, maybe in college students, and you wanted to make sure that you had students that were male and female, or maybe that's not a good example. That would only be 2 groups. But you could do that. I want half of them, I'm going to pull out half of them are going to be male, half of them are going to be female, and out of that you just randomly select 25 males and randomly select 25 females. So you're putting them in subgroups first, and then within each subgroup you're doing a simple random sample, meaning it's kind of like drawing names out of a hat, so to speak. So you could, and so here's an example. Suppose a particular state has previous data that indicated that the electorate was comprised of 39% Democrats, 37% Republicans, 24% independents. That's a lot of independents in that particular state. In a sample of 1,000 people, they would then expect to get about 390 Democrats, 370 Republicans, and 240 independents. Now, where did they get that number from? They're saying if there's 1,000 people and you were talking about 39%, 39% or 0.39 times 1,000 equals 390 Democrats. So they're just getting that from this information here. So, it'd be easier to think of even 100 people. It would be, If it was 100 total people, it would be 39 Democrats, 37 Republicans, and 24 independents. But they kind of come up with from previous data what those percentages usually are. And so if the Republicans are 37%, it'd be 0.37 times 1,000, 370 Republicans. And then do the same thing for independents. Those should add up to the 1,000. So what they're going to do is they're going to take those percentages. Okay, then what I'm going to do is I'm going to take the sample of 1,000 people that I'm going to ask something, to them. When I take that sample, I'm going to make sure that about 39% of them are Democrats. So that'd be 390 Democrats. So you would choose that first, those subgroups first. And then from each one of these, they're going to do a simple random sample on each one. So kind of the steps to this stratified is 1, put them in subgroups. And then 2, within each subgroup, they're going to do simple random sample. Okay. Now, the reason I went into this and kind of stressed that is this cluster sampling is next on the next page. The population is divided into subgroups or clusters. So that's the same as stratified. Stratified, you put them into subgroups. You do the same thing with clusters, cluster sampling. But so then once you do the subgroups, then the set of subgroups is then selected to be the sample. In other words, let's see, if a college, okay, I'm teaching 8 classes of students, okay? So I have 8 groups of about 24, 25 students each. And maybe I wanted to just say, okay, a population is divided into subgroups. It's my 8 classes. And out of that, a set of subgroup is selected to be the sample. So I'm going to pick 3 of the 8. 3 of the 8 classes. And that's going to be my cluster sampling. I'm going to choose everybody in those subgroups. So everyone in the subgroups or clusters chosen are sampled. Now, did they do that back up here when we talked about stratified sampling? Stratified sampling, they put them into subgroups. And then did they put them in subgroups and then poll or sample everybody? No. They're going to use a simple random sample. They may say, I'm just going to pick, I've got this many, 390, 370, and 240. That reflects what the whole population is by percentages. And then I'm just going to pick, out of 1,000, you're going to pick, randomly pick some of each group. Okay, we're here. What they're doing is they're dividing them into subgroups. Maybe there's 8 of them. And they're saying, out of that, I'm going to pick 3, and then I'm going to sample everybody in those 3. So that would be like I sampled everybody in my 3 classes. Rather than them then doing a simple random sample within the classes. I'm going to do everybody. So that's cluster sampling. If the college wanted to survey students, since students are already divided into classes, the classes are the subgroups. Subgroups or the clusters. They could randomly select 10 classes and give the survey to all the students in those classes. So the college is looking at all the classes, not just a certain teacher, like every class like this semester right now, and they wanted to survey them. And if they're using cluster sampling, they're already divided into clusters or classes, and they're randomly going to select the 10 classes. So when you randomly select with cluster sampling, you're picking out which subgroups or classes you're going to use. And they're going to survey all the students. That's my clue right there. That is cluster sampling. Cluster sampling, not stratified. Because stratified would be, they're going to put them in the 10 classes. They've got the 10 classes, and then they're going to do a simple random sample within each class of those 10 classes. Okay. Cluster would mean we're doing all of them, where stratified would be a simple random sample. Maybe you could remember with the S's. Stratified is simple random sample. Okay, voluntary response sampling. This is another type of sampling. So how many have we had so far? 1, 2, 3, 4, 5, 6. We're on our 6th one. 1, 2, 3, 4, stratified, 5, 6. Voluntary response sampling. This is allowing the sample to volunteer. So it's kind of like somebody, if y'all ever seen the usually girls, but not always guys too, standing at the mall like in front of a JCPenney or a Macy's or something. Maybe they're in the mall, but they're kind of right where the opening is to go in, and they're like, "Hey, here I've got these little examples of this perfume, and we wanted to see what you think about it. Would you try this?" And so they want you to try it and then tell them if you like it or not. They're asking for volunteers. Okay, so that's allowing the sample to volunteer. So, and they can do this on websites, on the internet now a lot. A website has a survey asking readers to give their opinion on a tax proposal. This is a self-selected sample in which respondents volunteer to participate. So self-selected means the people that end up that are in the survey, they kind of self-select, like I'm selecting myself to do it because I'm volunteering. Okay? So what would be the problem with that? Wouldn't it be that maybe you're only going to get a certain type of person that would do that? It's going to be somebody that has the time to do it. Some people are too busy. It might be younger people. Okay, back in my day, there's this big push on Pepsi versus Coke. And so Pepsi put these sample things all over everywhere where you could go and they would pour you a little bit of Pepsi in a cup and a little bit of Coke. You wouldn't know which one was which. It was like take the Pepsi challenge or something like that. And we would go do that when we were kids, like, teenagers or even younger. We were like, yeah, I'm thirsty. Let's go take the Pepsi challenge. Well, so you may get a lot of information from kids or teenagers or young people that they're just, or maybe people that are just thirsty that maybe can't afford to get something to drink. Hey, let's just go keep doing that. Like we used to do a lot of that kind of stuff in college because we were on such budgets that we would go to the restaurants where you could get the free Coke with it, or you get a better deal on food or something. So sometimes when you do that with volunteers, you're not getting a wide range of everybody. So that can cause problems. In each case, indicate what sampling method was used. So here's where you're going to talk about those 6 different kinds of sampling that we talked about and which one would go with one of these. Every 4th person in the class was selected. So you can go back up here and look. That was one of the first ones we talked about, wasn't it? Think about it like this. Okay, there's a system involved. Every 10th one or every 100th one, every fourth person, that's systematic. And you may be asked, well, why? Why do you think that? You could just say because it's every fourth person was selected or something like that. There's a system involved. Every so many, it wasn't just random. There's a system, systematic. A sample was selected to contain 25 men and 35 women. Ah. A sample was selected to contain 25 men and 35 women. I don't really like this one because that can be considered stratified because they're identifying into small subgroups, but that could also be clustered. You'd have to know more information on this. To me, if you were told that they're going to select and use everybody in those groups, that would be clustered. But I think what they're really saying is you're put in a group of maybe 100 men and 100 women, and out of that, you chose some of the men and some of the women. So that would be stratified. But I think this one's a little tricky. Okay, they're put into subgroups. But cluster was close to this because cluster you put into small groups and out of those you're choosing everybody. So you have to be careful on this. We would have to give you, I think, more information for you to be certain on that. Okay, let's go on the next one. Viewers of a new show are asked to vote on the show's website. That has got to be voluntary. The only people that are going to be doing it are the ones that volunteer to do that. So maybe maybe when America's Got Talent was new and they were asked to vote on it, that is all voluntary. They're not going to make you do it. That's voluntary. Viewers are asked to vote. And that's kind of a not very good example, what I said. Maybe this was the viewers of a new show, like, we want to know what you feel about this new sitcom. Like, is it funny? Do you like it? Whatever. And they ask maybe on the end of the first, pilot show, like, we want you to go in here and vote on it. So, but again, that's voluntary. A website randomly selects 50 of their customers to send a satisfaction survey. That got kind of cut off. But if they're randomly selecting 50 of their customers, that's a simple random sample. Okay? They're just selecting, randomly selecting them. Selecting randomly. Selecting 50 of all customers. I mean, as long as you said, they're just randomly, they're selecting them randomly, really, out of all the customers. I mean, that one's kind of self-explanatory, but to survey voters in a town, a polling company randomly selects 10 city blocks and interviews everyone who lives on those blocks. That one is where it's obvious. Randomly selects 10 city blocks. So that's our subgroup. And then they're going to interview everyone within those subgroups. That's cluster. Okay, because they divide it into subgroups. And then interviewed everyone. That was who those subgroups they choose, and then they chose the sample of some of the subgroups but use everything or everyone in those few subgroups. So remember the one earlier didn't say that exactly, did it? This one says interviews everyone who lives on those city blocks. Whereas up here, it just says a sample was selected to contain 25 men and 35 women. There's going to be those two groups, and then they're going to do more with them. So for it to be clustered, it's going to probably tell you that it's going to be everybody.
I'm just saying.
Hi, class. I just wanted to tell you that I'm going to take a break, and you're going to go on now to the part B, and we'll pick up right where we left off on the next video. So these are both going to be for homework 13 and 14.